Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Formative exercise 6.5. Number 1. Given tangent A plus B equals to 3 and tangent B equals to 1 over 3, find the value of tangent A. So, from tangent A plus B equals to 3, we expand the tangent with addition formula. Tangent A plus tangent B over 1 minus tangent A tangent B equals to 3. So we replace the tangent B by 1 over 3 and we move the denominator to the right hand side to times with 3. So we get tangent A plus 1 over 3 equals to 3 minus tangent A. So gather all the tangent A together. We have 2 tangent A equals to 3 minus 1 over 3, which is 8 over 3. So tangent A is 4 over 3. 2. Given that 3A equals to 2A plus A, prove each of the following by using suitable identities. A. Sine 3A equals to 3 sine A minus 4 sine cube of A. So we will break the 3A into 2A plus A. So with the addition formula from sine, we have sine 2A cos A plus cos 2A sine A. And from the double angle of sine, we can still expand the sine 2A into 2 sine A cos A times with the cosine A plus the expansion of cos 2A. We expand it with 1 minus 2 sine square A, so that most of the terms will be in sine function. So times with sine, then we have 2 sine A cosine square A plus sine A minus 2 sine A to the power of 3. And we want everything in terms of sine. So we can change the cosine square A into 1 minus sine square A. There we get 2 sine A bracket 1 minus sine square A plus sine A minus 2 sine cube A. Then expand the bracket, we get 2 sine A minus 2 sine cube A plus sine A minus 2 sine cube A. So lastly, we can get 3 sine A minus 4 sine cube of A. Prove it. B. Cosine 3A equals to 4 cosine cube A minus 2 cosine A. So same thing, we expand the 3A into 2A plus A. And then with the addition formula of cosine, we have cosine 2A cosine A minus sine A sine 2A. So cosine 2A, we expand it with the cosine formula, 2 cosine square A minus 1 bracket cosine A minus 2 sine A cos A times another sine A. So expand the bracket, we have 2 cosine cube A minus cosine A minus 2 sine square A cosine A. So we don't want any sine function here. So we change the sine square into 1 minus cosine square A. There we have 2 cosine cube A minus cosine A minus 2 cosine A plus 2 cosine cube A. So we have 4 cosine cube of A minus 3 cosine A. Prove it. Number 3. Given that sine x is 24 over 25, for x from 0 to pi over 2. So for this information, we know that x is actually in first quadrant. So with the opposite and hypotenuse, we can sketch out this triangle. Then we can find 7 as the adjacent. And cosine y is 8 over 17 for the y from pi to 2 pi. So from pi to 2 pi, cosine positive will be only in fourth quadrant. So we know the triangle we need to build is in the fourth quadrant, with the adjacent as 8, hypotenuse as 17. So we can calculate the opposite is 15. But because it is below the x-axis, so going downward, there we have negative 15. So come back, we need to find cosine x plus y. So expand with the formula cosine x cosine y minus sine x sine y. We have 7 over 25 times 8 over 17 minus 24 over 25 times negative 15 over 17. So we get 416 over 425. B, cosecant x minus y. So which is 1 over sine x minus y. So expand with sine addition formula. We have sine x cosine y minus cosine x sine y. So 1 over sine x 24 over 25 cosine y 8 over 17 minus cosine x, which is 7 over 25, and sine y, which is negative 15 over 17. So after simplify everything, we get 425 over 297. C, tangent x minus y. So expand with the tangent addition formula. We have tangent x minus tangent y over 1 plus tangent x times tangent y. So tangent x we get from 24 over 7. Tangent y we have negative 15 over 8. And then replace again to the formula 1 plus tangent x tangent y. So simplify the fraction. We get negative 297 over 304. D, secant of 2y. So secant of 2y is 1 over cosine 2y, which we can use 2 cosine square y minus 1. So we have cosine square y 8 over 17 square times 2 and then minus 1. So we get negative 289 divided by 161. E, sine y over 2. So y over 2 is half of the angle of y. We need double angle formula. So cosine y is the only double angle formula that involves sine. So cosine y equals to 1 minus 2 sine square of y over 2. So we can have cosine y as 8 over 17 equals to 1 minus 2 sine square of y over 2. So we have 2 sine square of y over 2 equals to 1 minus 8 over 17, which is 9 over 17. So now we get sine square of y over 2 equals to 9 over 34. If we want to take away the square, we need square root. And if we put square root on the right, then we will have plus minus in front. But why do we choose positive instead of the negative one? Look at our domain. Our domain of y is from pi to 2 pi. So when y change to y over 2, the domain is divided by 2. So pi divided by 2, we get pi over 2. And 2 pi divided by 2, we get pi. So y over 2 is actually in pi over 2, in between pi over 2 and pi. So which is in second quadrant. Second quadrant for sine is positive. Positive. So we have positive of 3 over 34. So rationalize the denominator, we have 3 times of 34 divided by 34. Number 4. Prove each of the following identities. A, cotangent x plus y equals to cotangent x cotangent y minus 1 over cotangent x plus cotangent y. So we will start with the left hand side so that we can expand with the addition formula. First, cotangent x plus y is 1 over tangent x plus y. Then we have 1 over of the tangent x plus and tangent y over 1 minus tangent x tangent y. So 1 over of this fraction, if I want to take away the 1 over, I got to flip this fraction upside down. So I have 1 minus tangent x tangent y divided by tangent x plus tangent y. So now, this is where we stop. Alright, how can we get cotangent x cotangent y and 1 as we have only tangent x tangent y? So we know cotangent x cotangent y is actually 1 over tangent x and 1 over tangent y. Therefore, for each of this term, we divide by tangent x tangent y, tangent x tangent y. This is forever on the first layer of our fraction. Then below we have tangent x plus tangent y each of them divided by tangent x tangent y. There, we will get 1 over tangent x times 1 over tangent y, which we get cotangent x times cotangent y. And then minus, we have common factor for this. After cut out, we get 1. Okay, so we have cotangent x, cotangent y minus 1 on top. And then below, tangent x and tangent x is the common factor. After cut off, we left 1 over tangent y, which is cotangent y. Then tangent y plus, and tangent y can cut off, and we left 1 over tangent x, which is cotangent x. There we get our right hand side. So cotangent x cotangent y minus 1 over cotangent x plus cotangent y. Proven. B. Tangent y equals to cosine x minus y minus cosine x plus y divided by sine x minus y plus sine x plus y. So expand with cosine addition formula. We have cosine x cosine y plus sine x sine y. And then minus cosine x plus y. So in the bracket, we have cos x cos y minus sine x sine y. Then divided by expansion of addition formula for sine. We have sine x cos y minus cos x sine y plus sine x cos y plus cos x sine y. So on top, the numerator, can we simplify? Yes, we see cosine x cosine y minus cosine x cosine y. So basically, we have no more cosine x cosine y. We have only sine x sine y minus negative of sine x sine y. So we get 2 sine x sine y. And then down here, we have sine x cos y minus cos x sine y plus sine x cos y plus cos x sine y. So the negative cos x sine y and the positive cos x sine y will form 0. There, as the denominator, we get 2 sine x cosine y. So again, find the common factor and cut off. We left only sine y over cosine y, which is the tangent y. Next, number 5. Given that tangent theta is t, okay, for the theta from 0 to pi, express each of the following in terms of t. So, regardless to the value of t, whether it's positive or negative, okay, it will be always true. Okay, we first put it in the first quadrant. Okay. So, for the tangent theta equals to t, so we have opposite over adjacent. So we know from the t, we have t over 1 in the fraction. Therefore, the opposite is t, adjacent is 1. So with the opposite and adjacent, we can get the hypotenuse. So express each of the following in terms of t. A, sine 2 theta. So sine 2 theta is actually 2 times of sine theta cos theta. So sine theta, we have opposite over hypotenuse. Cosine theta, adjacent times opposite. So we get 2 times of t over third t squared plus 1. Cosine theta is 1 over third t squared plus 1. So the third times third, we have t squared plus 1 as our denominator. And the numerator will be 2 times t times 1, which is 2t. So finally, we have 2t over t squared plus 1. B, cosine 2 theta. Cosine 2 theta can be expanded by cosine square theta minus sine square theta. So cosine square theta, 1 over third t squared plus 1, and then in square, minus sine theta, which is t over third t squared plus 1, in the bracket and square. So we get 1 minus t squared over t squared plus 1. C, tangent 2 theta. So tangent 2 theta, since we already get sine 2 theta and cosine 2 theta, then we can put tangent 2 theta as sine 2 theta divided by cosine 2 theta, which is 2t over t squared plus 1 over 1 minus t squared over t squared plus 1. And here, the two denominator is the same, so we can cut them off and become 1. So Finally, we have our final fraction as 2t over 1 minus t squared. D. Sine square of, D. Sine square of theta over 2. So again, theta over 2 is half of the theta. So the relation with the theta over 2 and theta, we can start with cosine theta equals to 1 minus 2 sine square theta over 2. So from here, cosine theta is 1 over third t square plus 1 equals to 1 minus 2 times of sine square theta over 2. So rearrange the things. We have 2 sine square theta over 2 equals to 1 minus 1 over third t square plus 1. So simplify the fraction. We have third t square plus 1 minus 1 divided by 2 third t square plus 1 as the 2 in front move downward. So our denominator is yet to be rational. So we times the third of t square plus 1 for top and below. So that our denominator now will become 2 times of t square plus 1. And on top we will get t square plus 1 minus third t square plus 1. E. Cosine square of theta over 2. Again, cosine square of theta over 2 can be related by cosine theta equals to 2 times of cosine square theta over 2 minus 1, as this is the half of the theta. So start with cosine theta. We have 1 over third t square plus 1 equals to 2 times of cosine square of theta over 2 minus 1. So now, if we want cosine square theta over 2, okay, with the 2 in front, we can just move the negative 1 to the left, become positive. So we have 2 times of cosine square theta over 2 is actually 1 over third t square plus 1 plus the 1. So after simplify the two fractions, we have 1 plus third t square plus 1 over 2 times of third t square plus 1. The 2 here already moved downward. Now, our denominator is not irrational. So we times the third t square plus 1. There we get the new denominator be 2t square plus 1 and the numerator as third t square plus 1 plus t square plus 1. Number 6. Prove each of the following identities. A. Tangent 1 over 2 theta equals to sine theta over 1 plus cosine theta. So we will start from the right hand side, as this is the double angle of the half theta. So from the right hand side, the sine theta will be 2 sine theta over 2 cosine theta over 2 over 1 plus cosine theta. We change it into 2 cosine square theta over 2 minus 1, so that the 1 minus 1 will become 0, and on top we have 2 sine theta over 2 cosine theta over 2. Below we get only 2 cosine square of theta over 2. Cut off the common factor. So we have sine theta over 2 over cosine theta over 2, which is our tangent theta over 2. Proven. B. Secant square of 1 over 2 theta equals to 2 over 1 plus cosine theta. So same, we'll start with the right hand side, as the theta here is double of the half theta. So 2 over 1 plus cosine theta equals to 2 over 1 plus 2 cosine square theta over 2 minus 1. There we get 2 over 2 cosine square theta over 2, as the 1 and negative 1 will become 0. There we can cut off our common factor 2 and 2. So now we left only 1 over cosine square of theta over 2, which is secant square of half theta. C. Sine 2 theta equals to 2 tangent theta over 1 plus tangent square theta. So we start from the right hand side and see. So 2 tangent theta, we can expand it into 2 sine theta over cosine theta. And then the 1 plus tangent square theta is actually 1 plus sine square theta over cos square theta. So we get 2 sine theta over cosine theta over cos square theta plus sine square theta over cos square theta. So now, the denominator is not the same, but we have common factor that we can cut off. Okay, and cosine square theta plus sine square theta is actually 1. So now we have 2 sine theta over 1 over cosine theta, where the cosine theta can move up to times with the 2 sine theta, where we get 2 sine theta cosine theta, which is sine 2 theta. Next, number 7. By using the addition identities, show that tangent theta plus pi over 2 is negative cotangent theta. So, for tangent theta plus pi over 2, we expand it with sine theta plus pi over 2 over cosine theta plus pi over 2, so that we can expand the sine formula, addition formula for sine. We have sine theta cosine pi over 2 plus cosine theta and sine over 2, sine pi over 2 over cos theta plus pi over 2 with the expansion become cos theta cos pi over 2 minus sine theta sine pi over 2. So we have cos pi over 2, which is 0, and sine pi over 2, which is 1. So now we have sine theta times 0, which is 0, plus cosine theta times 1, which is cosine theta. So on top, we left only cosine theta. Below, cosine theta times 0, which is 0, minus sine theta times 1, negative sine theta. So we have negative cosine theta over sine theta, where we get negative cotangent theta, proven. B, cosine theta plus pi over 2. So expand with the addition formula of cosine. We have cos theta cos pi over 2 minus sine theta sine pi over 2, where the cos pi over 2 is 0 and sine pi over 2 is 1. So we get 0 minus sine theta times 1, and we get negative of sine theta. C, sine theta plus pi over 2 equals to cosine. So expand with the addition formula of sine. We have sine theta cos pi over 2 plus cos theta sine pi over 2. So cosine pi over 2 is 0, sine pi over 2 is 1. So we have 0 plus cosine theta times 1, where we get cosine theta. Thank you.